Wouldn't that be something? I did it. I remembered. First thing I want to say is really, really nice work on test 3. It was exactly what I was hoping for, something to kind of, well, one, boost your grade, but also boost your confidence. And so I'm really, really pleased with how you guys did on test 3. And hopefully you're pleased with how it went as well. So I did go through and I adjusted things like I usually do. There wasn't a lot of work to go off of, but you know, some entries I could tell were just kind of typos. So I boosted some grades there, and if I felt like you should maybe have a little boost, then I did that for you. But yeah, just great work on test 3. I'm really, yeah, of course. Okay, so really, really good work there. And I'm happy. I'm happy with that. We didn't do any annuities due by hand, and it looks like we're not going to need to. So I don't want to spend any time working on doing annuities due by hand. You have the formulas on your formula sheet, but it looks to me like the final exam is going to be similar to what we just did. So, right, expect questions like those to come up again on the final exam. But I'm so thrilled because you guys did so great. Okay. I've also corrected, so I did test 3. All of the grades should be adjusted and kind of updated. So all test number 3 / quiz grades are updated / reviewed by me. Oh, I don't know what the average was. I suspect it was quite high, especially with the check your answer option. I think that really helped, and it helps to boost your confidence too. But I don't know what the average was, but I can find out. So, but now. Okay, so all of your grades are kind of up to snuff now. So, and they have been. I did that kind of early. Pat myself on the back for doing it before the weekend. Anyways, so let's see here. What I wanted to do was just get right into 7.2. So the last little stretch of material, this is our last week of classes. I can't believe it. It's usually kind of like a happy, sad time for me. It's like sad to let you guys go, and happy because it's almost summer. Now this term, it's feeling mostly probably happy. I'm sad to see you guys go, but I think we're all feeling the same way. So the last little bit of material that we have to cover is kind of these kind of special case annuities. So we're going to talk about deferred annuities, and also we're going to talk about perpetuities today. And then next day, what we're going to do is we're going to make a mortgage amortization sheet. So an amortization sheet, if you haven't seen one before, breaks down each payment, how much is going towards your interest, how much is going towards your principal, and then how much is left owing after each payment. And so we'll be able to generate an amortization sheet, and that's what we're doing next day. So today, we're doing 7.2, which is on deferred annuities. And 7.3, which is on perpetuities, which are kind of, I love the idea of a perpetuity, and we'll talk more about it, but, and then Thursday, we're gonna do 8.1, where we make a mortgage, or really any sort of, you pay off a loan, has an amortization schedule. Maybe that's what I'll call it. Is it 2 M's? I can't spell today. In my class earlier, I couldn't figure out how to spell cyclical. Isn't that so weird? Anyways, amortization might have 2 M's. It might not. Amortization schedule, right? Which is just a loan repayment schedule. So that's all we have to do so far, or this week. It's the last week of classes. So, and then if there's time, I'll do a quick run through of what to expect for the final exam. But just like before, I'll post a practice final as well. So that'll give you an idea of what to expect. So I'll save that for Thursday. Okay. There will be quizzes for each of these sections. So we will have 3 more quizzes. They're just going to be really kind of quick. But I'll make them due on the 23rd. So that's not this Friday, that's next Friday. So you'll have lots of time to work on them. And I haven't posted them yet because we haven't covered any of this. So I didn't want to freak you guys out. 7.2, let's start there. Deferred annuities. So a deferred annuity is when maybe we invest some lump sum and then we let that lump sum just sit there making interest, and then we get payments later, right? Think about, I'm not entirely sure of how a trust fund works, but it feels to me like your parents or whatever, they invest maybe some sum, right, when you're born or whatever, and then when you turn 18 or whatever, I don't know, I'm just getting this from TV, guys, so bear with me. But the idea is that lump sum, it just sits there for 18 years, and then you start getting these regular payments, right? So that would be a deferred annuity. You can apply that to anything really, but right, the idea is you invest some lump sum and then it sits there, and then you start getting these regular payments, right? Typically we're getting these payments, but it could be the other way around too. So a deferred annuity, is an annuity that doesn't start until some amount of time has passed. Is an annuity that doesn't start until some amount of time has passed. Some amount of time has passed. Okay. So in terms of a timeline, what does this look like? Well, in general, right, start our timeline here. This is what we'll call the deferral period. I won't really refer to it as that, but that's the amount of time that it's just going to sit there. You could also think about do not pay until January 2022, those types of ads, right? So then you're deferring the time until you start making payments, right? In that case, you would be making payments, but you'd also have to pay off the amount of time that you've deferred, right? Because then it's still forcing you to pay interest, but it's just putting off the payments. So what we have is we have some present value goes to some future value, which is going to be the same as the present value of the annuity. Okay, so here, if you're making some payments, payment, I'm assuming it's an ordinary annuity. We're not really going to deal with annuities due. Annuities due, right, have the payment at the beginning of the payment term or the payment period. Okay, that would just shift all these payments over by one kind of block, right? But let's just focus on payments at the end of each month or year or whatever, right? So here, these are going to funnel back to this present value. Okay. So what happens is we have some compound interest situation here because we're done with simple interest, right? So here, this is just what we call, or what I call compound interest. When I say compound interest, I mean you have compound interest but no regular payments. Okay, you still have compound interest happening here, but because you have the regular payments, it becomes an annuity, right? And so here, this is an annuity, which is chapter 6 or 7 or 7.1, usually 6, right? Because I don't want the payments to start at the beginning. They can, but I'm going to ignore that case. Versus here, this section is compound interest, which is from chapter 5. So you're going to link these up, right? Because you can use the compound interest formulas to find, for example, the future value. And then you also know that, okay, well, that's actually the present value of this annuity. And so then you can use the annuity formulas to find maybe what the payments are or how long it's going to take, or there's lots of things that we could solve for. So in terms of our formula sheet, right, here I've got this compound interest. I'm just going to use the future value formula here versus the annuities. And again, maybe I'll use both of them. And I'm going to kind of ignore this one for now, right? But we do need I2 to do our calculation. That's the I that we have to use. And then you can use these formulas, or you can just use your calculator, right? So what we're going to resort to doing is just using our calculator, because I've looked at the questions that we have to do, and the questions that we have to do are just asking, you know, what is this value, right? And then what is whatever the question's asking for. So we don't need to do it by hand, so I'm going to focus on the calculator. Okay. So now it will be really important to have the right sign for especially our payments, right? Negative payments means that I'm making these payments. Positive payments mean that those payments are coming to me. right? So that's going to be really important. And I'll highlight that again in the example so that we're about to do. Okay, so let's do a deferred annuity example. Okay. Today is the beginning of January. No, it's not, but here it is. So today is the beginning of January. Your bank offers, don't they know they're closed January 1st? It's like the only stat holiday. Anyways, your bank offers you an investment which pays $100 per month for 5 years, beginning in 5 years. So it gets confusing with 5 and 5, but that's okay. So we're gonna pay some amount today, and then we're gonna wait 5 years, and then after 5 years, I'm gonna get $100 per month for 5 years. Okay. With the first payment at the end of January. Okay. So if money earns a rate of return of 3% interest per year compounded bi-weekly, what's the most that you should pay for this investment? So how much is that investment worth today, right? You shouldn't pay more than that. Hopefully you would be able to pay a little bit less than that. But so I'm going to start with my timeline because especially for the first time when we lay this out, it's not obvious what these things are going to look like. So give myself lots of space here and say today is January 1st. Doesn't matter what year. I'm not going to use the days between dates calculation because we're talking about 5 years, and then for 5 years, I'm not going to worry about the dates. It's just to say that, hey, today is the beginning of the month, and then in 5 years from now, right? 5 years from now, would also be a January 1st. Okay. Okay. So that's all it's trying to get at. But then it also says that the first payment is at the end of January. Okay, so this is the tick for January 1st, but then at the end of January is essentially at the February 1st tick, right? So let's see here. Your bank offers you investment which pays $100, so that's the amount per month for 5 years. Okay, so here this length is also 5 years. Okay. So let me move this over here. Okay. So it's monthly payments. So I've got, I'll do 1 month, 2 months. 5 years is how many months? 5 times, oops, I'm in the wrong. 5 times 12 is 60 months. Okay. Notice it can be a little bit confusing because the overall length is not 60 months, it's 120 months. But I only care about this section for the annuity, right? So it gets a little bit tricky to look at, but right, overall we've got 5 years and 5 years. Right? So just keep those straight. 59 months, and I'm getting payments of $100 at the end of each month for 5 years. So what happens is we can figure out the value of $100 a month for 5 years. That's going to be the value on January 1st at the 5-year mark, right? Which is also the future value of of this amount today, right? And so we're gonna kind of, this becomes a two-phase problem. I like to think of them as a two-phase problem. So this maps back to some present value. Okay. And n is the number of payments, which is 5 times 12, which is 60, which we actually already have on there, but that's okay. Oops. It looks like what we have here is the interest. Let's just jot down just to complete this section. So that's what I'm going for, just to complete this section. But it actually looks like the interest is the same for all of these. That's not always the case, right? Maybe you have the deferral period, you're getting 4%, and maybe here you're getting 3%. Maybe this is 4% compounded daily, and this is 3 or 4%, I don't know, can't remember, compounded biweekly, whatever. You could have different interest rates for each section, okay? So here I am gonna make a note. We have R is 0.03 and the frequency is, or maybe I'll say the compoundings per year is 26 for both. And hopefully you guys are okay with me calling them phases, right? I'll call this kind of phase 1 and this phase 2. The hardest problem that we're going to do today and in the course, I would argue, is a 3-phase problem. Okay, so I like to think of them as phases. So here we have the same rate and the same compounding frequency for both phases. So for both phases, which is not always the case. Okay, so that's something that you want to keep an eye out for and adjust if you have different interest rates for the different phases. Each phase, of course, is going to have the same interest rate. We're not gonna do weird stuff like that. Okay, so what happens? Let's talk about phase 2 then. Well, phase 2 is, or kind of depending on if you're talking chronologically or how we're doing these calculations, because I have information about, I have everything that I need to find this present value. So I'm going to call this present value 1, but that's the same as this future value, right? And maybe I'll write it a little bit nicer here. I'll write it underneath. Okay, so once you have this present value amount, well, that's the same as the future value of this deferral period, right? So then you have the future value. And that's where it gets a little confusing, right? Because the present value too, how are you going to find it? Well, now you're just looking at compound interest here. N for compound interest is just the number of compounding. So N is 5 times compounding biweekly 26 is what? 130. Okay. Good. So, right, that's important because if there are no payments, then your N is the number of compoundings. Whereas if you have regular payments, it has to be your payment, the number of payments, right? So that's different. Okay. But how do we do this? Okay. We can do this by hand, But what I'm going to do is let's just use our calculator, right? So we could solve this by hand, right? Using the formulas. But we can also use the calculator. Okay. So what I'm going to do is I have to start over here, and this is where it gets a little bit weird, but I want to have my calculations so that I can just look up to my timeline and match my calculations to my timeline. So that means that I'm going to be working from right to left in this case, right? Because I want to know how much, what's the value of this investment today, right? Because this here, this is the value today, which is what we want to find, right? What is the most that you should pay for this investment? Well, you shouldn't pay more than the value of it today. So, okay. Using our calculator, right? I'm going to do my calculator entries for the annuity. And then on the left-hand side, I'm going to do the calculator entries for the compound interest. Okay. I like to have my calculator entries kind of matching my timeline. Matching my timeline. So what I'm going to have, right, calculator entries, we're so used to this now, and the interest per year, the present value, the PMT, the future value, the payments per year, the compoundings per year, and I'll just call it the mode, which is what we had on the test, right? It was called the mode. The mode, I can tell you right now, is the end, because those payments were at the end of each month. And then I can just grab a lot of this information, right? I can grab N is 60, my interest is 3. My N is 60, my interest is 3, my payments per year is 12, my compoundings per year is 26. All of this, right? Annuities on their own, I know you guys are really quick at now, so that's why I'm moving kind of quickly. So here, I'm going to put a star here because that's the one that I want to solve for. How we entered it on the test, right? You had to enter 0 in the spot that you were solving for and then give me the answer down below. But I also have a page break right here, so I'm not going to do that. I'm just going to put it here in this slot. Doesn't matter. Now, what's important is that, okay, the PMT, because I am getting these payments, I'm getting $100, I have to make it positive. So it's positive because I'm getting these numbers. And maybe I'll emphasize it with a little plus in front, right? Because you want to keep track of, and of course on the Moodle quiz it said to don't include any negatives when you enter those values. But of course, when you're actually using your calculator, you have to have the negatives. So that's going to be important. Once this is all used up, so here, right, this present value is being used. So we're taking from this present value, or the bank is taking from this present value, and they're making payments of $100 for 5 years. And then at the end, it'll all be done, right? It ends because there's no more money. So then the future value here must be 0. Okay. So I am going to cheat and just grab these calculator entries and replicate them over here for the compound interest. Okay. And before I go ahead and do that, I'm going to find this present value. Okay. So we'll use our calculator. I'm just trying to remember these entries, 63, 100, 12, 26. Okay, we'll see how I do. Okay. First thing I'm going to make sure, because otherwise I might forget, is I want to make sure that I'm in end mode, which I am, right? So, and if you want to change it, you have to hit second enter. Second quit. Okay, so I have 60 for N, 3 for the interest per year. I'm going to put in 0 for the present value, even though you could leave it blank if you wanted to, but 100 for the payments positive, 0 for the future value. Payments per year is 12, enter. Compoundings per year, 26, enter. I always like to scroll up to make sure my payments per year didn't change. And then I can quit and compute my present value. Okay. So I get, let me see if I can grab this. Okay. I better just jot this down here. Let me grab some scrap paper. 5564.957846. If you wanted to just use 2 decimal places right away, just make sure you round properly. But what we get here is we get, and I'll do it in pink so we can see what happened here. We get negative 5564.957846. Okay. This negative, right? This negative tells me that that's an amount that I would need to pay in order to be able to get $100 per month for 5 years, right? Makes sense, fair enough. But this negative doesn't necessarily hang around when I bring it over here. So remember that this present value becomes this future value, right? And we can look at our timeline here. But what we've found is that this is the 5,564, right? But that's also the future value of just the compound interest. So what I'm going to do is I'm going to bring this down here, right? So now I'm linking this up, but what's important is that I get this amount, right? So the idea is you invest present value 2 means you give it to the bank, right? So it leaves your hands, so that amount has to be negative. Then you get that total amount, the 5,564 that we just found. Then you immediately put it in again. So then you deposit it again, and then you get these payments, right? Okay, so it's really important that you keep track of these positives and negatives now. So this, I'm going to make a positive amount, 5564.96. And I would round these to 2 decimal places because these are dollar amounts, right? So when I bring it over, I'm just going to round to 2 decimal places. Then I can grab some more information from the timeline, right? So the interest per year was the same. Notice that it wouldn't be a big deal if it was different, right? You would just have to adjust it. So if this was 4% compounded daily, right, then you would have 4 here and 365 here. Yeah. So in this case, they're the same. So I know I have compounding 26 times per year biweekly. I'm going to go up and grab my N. my N for this section is 130. And I'm trying to find the present value. So I'm going to put a star there for the present value. Just grabbing a couple of things here and put a star by the present value. That's what I'm trying to find. There are no payment amounts, right? So remember when we first started using the calculator, we didn't have payments. So then we would just enter 0. That's fine. What we had to do for the payments per year was we just forced it to be the same as the compoundings per year, right? Because there are no payments, so you just force it to be 26. And then the mode, make sure you're in end mode. It actually doesn't matter because there are no payments, but just for simplicity's sake, use your end mode. Okay, so now I'm gonna enter these values and find another, the second present value. Actually look kind of fun. Okay, so I'm gonna clear that. Oh, I can't remember my N, 130, I think. I feel like it was. I have to go back. Yeah. 130. 3. Okay. I got it. So my N here, thank you. I should just look at the chat. You guys are so on it. I'm like trying to figure it out here. You guys are like 130. Okay. The interest per year is still 3. I'll put in 0 for the present value for right now. And then again, there are no payments. So I'll put 0 for the PMT. The future value is going to be that 5564.96 is my future value. I'm going to make it positive because I'm in theory going to get it and then invest it immediately. And then I want to adjust my payments per year to be 26, enter. Notice when I change my payments per year, it'll always just force the compoundings per year to be the same. And then if we need it to be different, we can go and change that. But anyways, so good. I'm in end mode. If I wasn't in end mode, if I was in begin mode, I'll remind you, notice that it has this little BGN up at the top on the screen. So that's a reminder to you that, hey, you're actually in begin mode. In this case, it doesn't matter because there are no payments, but I just wanted to show you that that's one way that you can check it. So just check the top of the screen. There's no BGN. Okay, you're good to go. So now I want to compute the present value. And again, I'm going to jot this down. 4790.219662. Good. Come on. So then the value of this thing today is 4790.219662. Okay, so then from here, oh, I wish I could. I just need one more line, so I'm gonna bump this. I'm gonna cheat so bad. So then here, therefore, the value of this investment today is $4,790.22. The value today is $4,790.22. So the idea here is if the bank said, hey, if you give us $4,500 today, then in 5 years from now, we'll give you $100 per month for 5 years. That's a good deal. That setup is worth $4,790 today, right? And they're selling it for $4,500. So that's how you would use these, is to determine, okay, well, how much should I be paying? If they say, oh, you just need to give us $5,000 today, and then 5 years from now, we'll give you $100 per month for 5 years. Sound good? Sign here. No. No, thank you. It's not a good deal. Okay. Maybe you just desperately want to get rid of $5,000 now and have less later. Right? And so that's how you would use these. So pretty fun to link up these situations. Of course, it makes reading and understanding the question a lot harder, right? But if you can pick apart kind of into different phases, then you know how to deal with each phase. Okay. All right. So I want to show you. So this example I've actually added because there's nothing quite this difficult in the textbook. But this is like the hardest type of problem that we could possibly do in this course, okay, or from what we've learned in this course. Now, there's nothing like this on the final, but there is something like this on the final. So I'm going to focus on perpetuities, which is kind of the last concept from chapter 7. And then we're going to come back to this one and really break this down. But let's just read it so we can kind of think about it. We'll stew on it while we work on perpetuities. So if you're investing into an RRSP for 15 years, so you're making payments for 15 years, then you have an annuity. And then we're going to let that amount of money, is the final this Sunday? No. The final is on the 26th. Yeah. But also there are no finals on Sundays, only on Saturdays and the other weeks. But Saturday is the weird weekend one. Yeah, perfect. Thank you. So on the 26th from 6 to 9 is our final. Yeah, you shouldn't have any Sunday exams on there. That might be the wrong year, actually. I don't know. I teach this course a lot, so I would be on there anyways. But anyways. Okay. So you're making payments for 15 years. But then you're going to retire in 27 years. So 15 years you're making payments, and then it's just going to sit there for some amount of time, right? 27 minus 15. And then after you retire, you want your RRSP to pay out $2,000 at the beginning of each biweekly period for 20 years. So then you want payments for 20 years. So you're making payments, letting it sit, getting payments. A 3-phase problem. And that's like the hardest thing we can do. And there is a quiz that will be like this. But you can do it. So before we get into that, maybe I'll grab this example here. So 7.3, so I'm kind of parking lotting that huge example, and then we'll do perpetuities, and then we'll come back to it. So 7.3 is on perpetuities. The only section that we're not doing is 7.4. You can actually do 7.5 still. It's just these kind of more involved problems, right? And so you have all the skills to do 7.5. That's why they're included in those extra practice problems that I posted. So you can still do them, but they're gonna require you to put things together. So perpetuities. Perpetuities are like the coolest thing. So perpetuities are just where you invest some amount. So you have to have some present value, but then you're gonna get these payment amounts. So you're gonna get some payment amount forever, okay? And so a perpetuity, and you can kind of tell from the name, right? Perpetuity, perpetual, so forever. An annuity whose payments continue forever. Forever. Okay? So that's pretty awesome. Okay. The idea is that you're just skimming off the interest, right? So at each compounding period, you're just taking the interest and that's your payment amount. Okay. So at each compounding period, you get the interest amount, which becomes your PMT. You get the interest earned and that becomes your PMT. This leaves the initial, the present value intact, right? So you're not taking from the present value, you're not taking from that initial investment. It's just going to sit there. So let's say it only really works for large amounts. So let's say you have $1 million, right? You're, I don't know, Irving K. Barber. He owns like all of UBC. Anyways, or Fipke, local guy, geologist, I think. Anyways, so you have $1 million. Oh, what am I gonna do? $1 million? Oh man, I don't want to lose from this $1 million. So then you invest it, and even at a really low interest rate, let's say you get a monthly interest rate, compounded monthly, right? Then each month you would get that little bit of interest that you've earned off of your $1 million. You leave that $1 million. So at the end of each compounding period, you end up with $1 million. So the present value and the future value are always the same, right? They stay $1 million forever because you're not getting into it, right? So at each compounding period, you get the interest earned, which leaves the initial investment untouched forever. All right, so pretty cool. Okay, what we can do, of course, is we can combine a deferred annuity with a perpetuity. But first, let's look at the formulas for perpetuities. They're really nice and breezy. Okay, where's our formula sheet here? Notice at the bottom, are these the best looking formulas you've ever seen or what? Right, so you've got the present value of the perpetuity. Okay, so that's the initial amount, the $1 million that you've invested. And it's going to be the payment amount over I. I is going to be I2, right? So because you've got some payment frequency and maybe some compounding frequency. And so this I is going to be I2. Okay, if you're doing this by hand, which we have to do because the calculator can't handle perpetuities, right? So we have to find I2. This is the amount that you're getting after each payment period or compounding period, right? Payment period. If you have a perpetuity due, it just means that you have to have that first payment ready, and then it can pick up. So it's basically a perpetuity due is just, okay, we'll have that initial payment ready. So you have to add that to the initial investment. You take that out and then you start, and all your payments are at the end of the payment period. Payments are at the end of the payment period. Whereas here, a perpetuity due, right, just means we have to have the first payment available. So here, if it's due, payments are at the beginning of the payment period. So we need that first PMT ready, right? So we need to have the first PMT ready, right? As part of our present value, as part of our PB, right? And so that's why nothing else has changed here. You just need to add on that last or the first payment that you're getting. Okay, so we ready to do one of these? Let's do it. Oh, I already copied it. Copied. I'll put it on a fresh page. How about? Oh, I copied it and then I copied something else and now it's gone. Okay. Let me just get there. Huh. Okay. Well, it's all crooked. Oh, no. It's like writing on the whiteboard. I always write like this. I haven't written on a whiteboard in a really long time though, but so phew. Okay, so to me, this course, right at this point, now that we've introduced all these concepts, it's really like Sound of Music. When you know the notes to sing, you can sing most anything, right? You have all the formulas, we can put them all together, and we can tackle some really big problems. Everyone knows Sound of Music, hopefully. I was obsessed when I was a kid. I was like 10 and really, really obsessed with Sound of Music. Anyways, so it makes me think of that. But so in this case, we've got a donation of $350,000 and it's being made to support youth sports in Kelowna. So in order to hire a part-time you need to pay this administrator $25,000 annually, okay? And we need to have that ready at the beginning of the year, okay? So that's what tells me when are these payments being made. Well, they have to be made at the beginning of each year in perpetuity. So these payments, so this $350,000, it's going to need to sustain $25,000 per year forever, right? What does that mean? Well, it means that the interest that I'm kind of skimming off the top each year has to be $25,000, right? I also have to be ready to make that $25,000 payment at the beginning because there's no other way to adjust for it. So if we did the calculation, then this $350,000 wouldn't cover it, right? It would cover some payment amount, right, which we could look at. But let's focus on the problem. But you could figure out, okay, well, what payments could we get out of 350,000? Okay. For us, we're going to let this 350,000 sit for some amount of time, and then we're going to get this perpetuity going. So how long should the organization invest the 350,000 at a rate of 5.5% interest compounded semi-annually so that they can hire the administrator? Okay. So now, okay, let's force all this together. First thing I'm going to do is I'm going to look at the timeline, figure out what's going on here. I'm going to do an arrow here because it's in perpetuity, right? If you forget to do it, well, one, I won't really be marking your timelines for this stuff as much. No, I'm not going to say anything about the work. I'm going to look into it. I got an email and I read it. Now I can't remember if we have to take your work or no. I'll tell you on Thursday. Anyways, for a perpetuity, I just draw an arrow saying, hey, this continues forever and ever. There's actually no end. So at some point here, we're going to start getting payments of 25,000 per year, right? So here, after some point, right, I get 25,000 at the beginning of the year. Then 1 year after this unknown time point, right? So now in terms of the perpetuity, this starts the perpetuity, and then for each year after, I get $25,000. 2 years, 25,000. Oh, yeah. 3 years. I usually show 2 or 3 points. It's okay. As long as you show me that it keeps going here, right? It keeps going forever and ever and ever. These values, I can still funnel back to this time point here as some present value. This is a perpetuity, and it's at the beginning, right? Because the first payment is made at the beginning of the first year. So this is a present value of a perpetuity due. Okay. Okay. So now, if we go back to today, someone gave us 350,000, which has to grow to some future value, which has to, so this is the same setup as before, right? Except now this calculation is a perpetuity, which we haven't done before, so now we're doing them. So for the present value of the perpetuity has to be the same as the future value of this 350,000, right? And to find how long is it going to take, we need to find n before we can find t. So here on this arrow, I'm going to say n is question mark. So here I'm going to say note, we can't solve perpetuities using the built-in financial functions. It can't handle perpetuities. Note, we can't solve perpetuities using financial functions. But what I will say is that I can still do these calculations kind of, and it takes some getting used to. And if you don't like it, if you like to work left to right always, then that's fine. I just like to match up, okay, this section I'm gonna calculate the present value of the perpetuity. And then on the left-hand side, that's where I'm gonna do my work in finding n. I know that's weird, but I just like to have it so I can look at the timeline and match it up. I also have a rate of 0.055, and my compoundings per year is semi-annually, so 2. Okay. Notice here that my payments per year is 1. Okay. So what I need to do, and again, it looks like the interest rate is the same for both of these phases, right? Not necessarily the case, but it makes it a little bit easier. So what can I do then? I can find my present value of the perpetuity due, but I first need to find I2, right? So here, I2 is 1 plus I1 over to the power of F1 over F2, then minus 1, which is 1 plus 0.055 divided by 2 to the power of 2 over 1 minus 1. Okay, so I'm going to do this on our calculator. I've got 0.055 divided by 2 plus 1 to the power of 2 over 1 is just 2, and then minus 1. So I get, let me jot that down, 0.05575,625. And I'm going to store this in 1. Point 0.055,756,25. And I'll make a note that I stored that in 1. Here's the thing. This is the rate if I'm compounding annually now, right? It has to match my payment frequency. So you have a couple of options, right? If you're working by hand for this next section, I would probably just use my compounding frequency as 1 and just use this rate or the I2 as my I. I'm going to use a calculator to do these, so it doesn't matter, but I do want to show you that might make it easier, right? But this has a new compounding frequency of 1 instead of 2. So now my present value of my perpetuity due from our formula sheet is the payment amount over I plus the payment amount, where I is I2. Okay. So we need 25,000 as our payment. Over store 1 plus 25,000. That's really just saying, okay, well, our initial investment can only handle payments at the end, so you better have that first 25,000 ready. We'll take from that and then we'll start fresh. So now if we go to 20, super truck. Okay, so I need to do 25,000 divided by, recall 1. Okay, so if I wanted 25,000 at the end of each year, I would need to have $448,380.23, just to make sure. But then I need to have that first 25,000 at the beginning of this year, so plus 25,000. I better jot down that first number too, 473,380.2264. Going backwards a little bit here, because you know I don't do math in my head. Okay. Now I can jot these down. Or, come on. Hello. Should get too much. So this is 448,380.2264 plus 25,000. So then I need a total of 473,380.2264, which means in money, my initial investment has to be $473,380.23. So that's how much at 5.5% compounded semi-annually, right? Depends on the interest rate. And that's quite high, right? So you need a little less than $500,000 to be able to just scrape off 25,000 a year, right? That's really satisfying, I think, to think about, okay, then you're just scraping off and living off the interest forever, right? Because you're not actually chipping away at this amount. So what we need then is we need the initial gift, 350,000, to grow to 473 whatever thousand, right? So for this next part, you can use the calculator, or you can use just the formulas if you want to do it that way. I'm going to work with the calculator because it makes it a little bit easier, but I need n, which is actually what I'm solving for. So here I'm going to put a star. The interest per year, the present value, the PMT, the future value. It's also nice to work with these calculator functions, but because we haven't done a lot with just compound interest, right? We really got into it when we introduced payments, but we didn't do a ton without payments. We did some, but it was like just as easy to do the calculations by hand. So I'm trying to solve for n, the interest per year, and here's where I actually prefer, if I'm using the calculator, and that's if I'm using the calculator, I would use this 5.5% compounded semi-annually, because that is given to me in the question. So I don't want to rely on something that I've come up with when I could just as well grab it from the question, right? So I'm going to use the 5.5, and it's compounding semi-annually. The present value is 350,000. Now the idea is, okay, so we get this 350,000, and immediately I take it and I deposit it, making this value negative. And then in theory, I get this money, right? So it's going to be positive. And then I deposit it again to set up this perpetuity, right? So thinking about positives and negatives. So here, this present value, I'm going to use negative 350,000. There are no payments, so I can use 0, that's okay. The future value has to be this value here, right? And so this becomes the future value. And I'm going to make that positive, right? For these compound interest problems, as long as one of the present values is negative and the other is positive, it'll still work out. But I want you to work on positives and negatives. So positive 473,380.23 We force the payments per year to be the same as the compoundings per year because there are no payments per year. And the mode, just make it the end mode. All right, that's our default. So now we have everything. Now we can solve for n. Okay. I'll put in 0 for n right now, just so, because otherwise it feels like I didn't do it properly. 5.5 for the interest per year, negative, 350,000 negative for the present value, 0 for the payment, and then that 473,380.23 positive for the future value. Otherwise, if both of them are positive or both of them are negative, it'll give you an error. It doesn't like that. Payments per year, force it to be 2 because it has to be the same as the compoundings per year, but notice that it adjusts it anyways. So now I can compute n. 11 point, and I gotta jot it down again, 11.130874006. So let's see here. N is 11.130874006. So it's going to take 11.13 compoundings. Okay. Remember what we have to do though? We have to round up, right? Because this 0.13 of a compounding is basically a partial payment. But in terms of the number of payments, even if I'm paying $500 a month and then the last month just to pay off, I'm paying $200, that's still 12 payments in this case, right? So I always have to round up, even if one of those payments is a partial payment, right? So how long is this going to take? If I only went for 11 compoundings, I wouldn't quite be at this future value, right? And so we need n equal to 12, right? Compoundings. But n is the time times the frequency, so 12 is the time times, and here, right, n isn't the number of payments anymore, it's the number of compoundings, so the frequency is 2. Oh yeah, I should mention, Moodle, if it's telling you that it's wrong, if your t turns out to be wrong, try using the unrounded n, because Moodle isn't very clever. So depending on, if someone has spent time forcing it to round up, not likely, then try using the unrounded value, right? But try it with the rounded value first, because that's what it should be. And then if it tells you that it's wrong, try it with the unrounded value and see if it works. I'm pretty sure that you can store, for example, if I want to store this 11.13, I wonder if I can store it. Can I store this in 2? Let's see, recall 2. I can. Cool. Just a little fun thing to try. It worked. So if Moodle's giving you grief, try the unrounded value, but it should be rounded. And that's one of those things that if you've used the rounded value, not on an assignment, I won't change it because I haven't checked the assignments, but on a quiz or on the test, then I would give it to you anyways. But in this case, the time becomes 12/2, which is 6 years, right? So we would have to wait 6 years for that 350,000 to grow to the 473,380 and 23 cents. Then after that, we would be able to get 25,000 at the beginning of each year forever. All right, so pretty cool. It would take 6 years until we can hire an administrator. Until we can hire an administrator. Imagine just getting all your pay at the beginning of the year. I don't think it would be good. I don't know.
So for this one, when it says at the beginning of the year, that doesn't, I changed my mode to beginning and then like you said end. So you just ignore that?
So the beginning is for these guys here. So for this section, it would be beginning, but because it's a perpetuity, we can't use the calculator functions. And then here, there are no payments. So you would find the same future, or you would find the same end if you had it in begin mode, because the begin or end tells you when these payments are made. But if $0 payments are being made, it actually doesn't matter if it's at the beginning or the end. So a little bit tricky. For my default, I like to have the end, especially if I'm working with $0 payments. So,
okay, that makes sense. Cool. Thank you.
Okay, no problem. So we can also work backwards. For example, if we know how much exactly. Yeah, so there are lots of different ways that we could slice and dice this thing, right? So even if we have the same timeline, right, same kind of situation, right, I could say, okay, well, if I let this 350,000 grow to 500,000, what payment amount could I sustain forever at the beginning of the year or at the end of the year, or maybe at the beginning of the month or end of the month, right? So kind of the timeline stays the same, but the unknown or the thing that you're ultimately solving for might change, right? So there's a couple of different options, but yeah, totally. So you could be given this amount and this future value, and maybe even this length of time. And then you might have to find what amount could you get, right? Good. Okay. Are we ready for the hardest question of this course? It's pretty fun once you kind of wrestle it down. Okay. So the following example contains annuities, frustrations, and complications. The following questions, or the following question, is the hardest type of question we solve in this course. Is the hardest type of question we solve in this course. Okay. That's just to give you an idea of, okay, if you can handle this question, you can handle anything that I throw at you. Okay. So that's good. But let's see here. So here, copy. Here it is. Oh, didn't change the font. Oh well. Maybe what I'll do is just want to blow up so we can read it a little bit better. There. Okay. So we already read it. We've kind of been exposed to it. We've had some time to maybe think about how we would solve this thing. Okay. So here's the situation. You've decided to invest in your RSP over the next 15 years. Okay. You'll make monthly payments starting at the end of this month. Notice that it doesn't say what those payments are. Oh, boy. Oh, brother. That means we're going to have to solve for those payment amounts, right? Starting at the end of this month. You plan to retire in 27 years. So you're making payments for 15 years, but then for some amount of time, you're just going to let it sit there. So until you retire. And then after you retire, so here, then you want your RSP to pay out $2,000 at the beginning of each bi-weekly period for 20 years. Okay. So the hardest part is mapping out this timeline. And then once we have the timeline, everything will just kind of fall into place. I promise. I'm going to do the full length of time. So starting today, we have a cutoff point at 15 years. And in general, and maybe what I'll do is I'll put this time point a little bit up higher, 15 years. And then I retire in 27 years from today. And then 27 years, and then you want your RSP to pay out some amount for 20 years. So this length of time has to be 20 years, right? And so that puts me at 47 years from today, right? Because this length has to be 20 years. This length has to be 15 years. The distance between 27 and 15 is 27 minus 15, 12. Okay. So here's the situation, right? Now that we have these kind of time points, right, I see that this is going to be a three-phase problem, okay? And because we read the question and we said, hey, I actually don't know what my payments are. I know they're monthly and they're going to start at the end of the month and that's it for 15 years. So it looks like I'm going to have to find this PMT. Okay. All right, what that means is I'm going to have to start over here on the right-hand side and then figure out probably the present value and then use that as the future value and then figure out the present value and just kind of work my way backwards, okay? You can definitely have a question like this where you're working forwards, right? There's lots of different ways that we could ask, but in general, this is a three-phase type of problem. Okay, so let's jot down kind of information as it comes up in the question. So you've decided to invest in your RSP over the next 15 years. You'll make monthly payments starting at the end of this month. Okay, so to show that 1 month, 2 months, and I'm going to make some payment amount, PMT, 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 because it's at the end, right? So how I show that it's at the end is I start the payments at the end of the payment period. Okay? 15 years is how many months? 15 times 12 is 180. Oops. 180 months, making this 179 months, right? For each annuity, I still want to see the first 3 ticks and the last 2 ticks, right? It's going to get to be very crowded, this timeline, but that's okay. So this, there's no mention of me having some amount initially. That would make it even harder, right? But this is as hard as we're going to go. So you start with nothing, and then you make these payments, some unknown monthly payment amount. And after 5 years, you have some future value, right? So this is some future value. I'm going to hold off on numbering these future values and present values, because the numbers, I want to use them to help me figure out which order to do the calculations, right? And so this future value is among the last things that I'm going to find. So that's why I'm not numbering it yet. Okay, so you make monthly payments starting at the end of this month. Okay, we're done with that. You plan to retire in 27 years. We've also handled that. After you retire, you want your RSP to pay out $2,000 at the beginning of each biweekly period for 20 years. So we've already set this up to be a length of 20 years. So what this means is that I have 1 biweekly, 2 biweeklies, oops. And then remember, the length of this annuity is 20 years. So 20 times 26 is 520 biweeklies. Oops, biweeklies, making this 519 biweeklies. And I want $2,000 payments at the beginning of each biweekly period. So that means that at this point, at the 27-year mark, I want that first $2,000. Gimme, gimme, gimme. Happy retirement. Here's $2,000 to start you off. Hey, pretty good. I got it figured out. 2,000, 2,000. And if you have, kind of give yourself a lot of space. I don't have a lot of space on the iPad, so it's going to be a little bit cramped, right? But that's okay. So you want it to pay out $2,000 at the beginning of each biweekly period for 20 years. We've got that on our timeline. If your investment earns 6% compounded semi-annually, what are your monthly payments? So it's asking, what are these monthly payments, right? So to get there, I can figure out the value of these payments at the 27-year mark, right? As long as I make sure that I'm either in, oh, whoops, what did I do here? What did I do wrong, I should say? I put 2,000 here, but they're all at the beginning, so that's not there. Sorry about that. All right, they're all bumped. But to show that these are all at the beginning, this is going to funnel back to some present value due, right? Because I want to emphasize that, hey, this is actually, these payments are at the beginning. So this becomes some present value due at the 27-year mark. Hey, this is backwards. So this future value is the present value at the 15-year mark, and this present value is the future value at the 27-year mark, right? And so here, this actually becomes the present value, which has to grow to this future value, okay? Here, you just have compound interest. There are no payments, so it's just a compound interest problem. Whether you want to do that by hand or on your calculator, it doesn't matter. For kind of, I don't know, consistency, I'm going to use the calculator functions for each of these 3 phases, right, or sections. I will jot down the ends on each of these arrows because I have them for the most part. So here n is the number of payments, which is 520. Here n is the number of payments, which is 180. The difference here is n is the number of compoundings, right? So here n is 12 and we're compounding semi-annually, right? So n is 12 times 2, which is 24. Just remember it has to be, so as long as you're switching to compound interest, you need to figure out your n is the number of compoundings, not the number of payments. Okay, so now I can kind of, well, okay, so last thing I guess is that for all of these, the rate is 0.06 and the compounding per year is 2. And that's true for all of these, right? So I'm just going to jot it down somewhere around here. Right. Okay, so let's figure out the order of our calculations. Like I said, if you're trying to figure out something unknown on the left-hand side, you're going to have to start over here on the right-hand side. This could have just as easily said, what are the payment amounts that you're going to get bi-weekly or monthly or whatever, right? So you can figure out pretty much any situation here. But in this case, right, we want to find this payment amount. So I have to start over here on the right-hand side. So what I'm going to do is I'm going to find this present value first, right? So this is going to be kind of my my first calculation. Okay. I'm not considering the switch from the present value to the future value as a calculation. It's not, you just use those numbers appropriately. But then what I can do is I can use that number to find this present value. And then again, I'm going to use that as the future value, right? So that switch I'm not counting as anything in particular, right? But here, finding this value is calculation number 2. And then my third calculation is going to be finding these payment amounts in phase 3. Okay. So I'm going to use the calculator functions. It's way too much work to do by hand, especially because I'm running out of time. So here we go. I am going to cheat and copy and paste my calculator functions 3 times over because I can. So n, and notice that I like to kind of line them up with some cutoff points. So I like to line them up with the timeline. That's just personal preference, right? So n interest per year, present value, PMT, future value, payments per year, compoundings per year, and the mode. And like I said, I'm just going to copy, paste, and paste. Okay. So because I have this annuity due, I'm going to make sure that I have the begin mode just right off the bat. Okay. And we already know is 524 this phase, right? And so, and the interest per year is 6 and the compoundings per year is 2 for all of these. So one thing I can do is I can just put those in for all of these well, they are computer entries, calculator entries, because they don't change. That is something that could change on a different question, right? Maybe the interest rate is different for all these phases. It's way too hard, but it can happen, right? It's mostly hard to phrase in a question that makes sense, right? So that's why I'm just using the same interest rate for all of these. 6 and compoundings per year is 2. 6, 2, 6, 2. Okay. Because those are the same, so I'll just kind of get that off my to-do list here. The present value is what I'm trying to solve for here, right? So I'm going to put a little star here. Okay. And my payment amount has to be $2,000. Now, let's think about this. Okay, so I'm getting $2,000 biweekly. Okay, so let's make that value positive. So it has to be positive because I'm getting that value. After 20 years, funds are gone, right? I can't get any more payments, so the future value here must be 0. Okay. The payments per year are bi-weekly, so 26. And to save us a little bit of switching back and forth here, because I'm just using the calculator entries, I'm just going to do it on the side here. And just make sure that you get the same values. So N is 520, 6 interest per year. I'll enter 0 for the present value temporarily, 2,000 for the payment, 0 for the future value, 26 payments per year, enter, and 2 compoundings per year, enter. Scroll up, just make sure it stayed the same. I have to change the mode, right? Make sure you're in begin mode. And you should get compute the present value. You should get a present value of negative 610,648.1281. If you got something that's just slightly different, check your mode, right? That's probably where you went wrong. To color code this, I am going to block this off in green because this is going to be used as my future value down here. That doesn't look like an arrow. Okay. So what that means is, okay, well, when you retire at the 27-year mark, you're going to need to give the bank 610,000, whatever, and then it'll give you these payments. It'll kind of dole out these payments for 20 years. How does that future value behave here? Well, it's really kind of, you get this future value and then you invest it right away, right? So let's make that future value positive here. So 610,648 point to 2 decimal places. I'm going to go 0.13. Yeah.
I think you wrote it on the wrong line.
Oh, wait, say that again.
Did you mean to write it for your future value?
I did too. I even have an arrow here. Mega fail. No harm, no foul. Thank you. That would have been really confusing later. Like, why isn't it working? Thank you. Good. So then here, remember for this stretch of time, there are no payments, right? And so a couple of things change. I force my PMT to be 0 but I'm also going to force my payments per year to be the same as the compoundings per year. And it doesn't really matter, but I'm going to force my mode to be at the end mode just because, I don't know, for consistency. I don't want someone looking back at these notes and going, hey, why was it at the beginning? But honestly, you should get the same answer even if you stay in begin mode for this phase. So my n here is the number of compoundings, right, which has to be 24. And I'm trying to solve for the present value. So here we go. So again, I'm just going to do it over here on my real calculator. I'm going to change my mode right away to the end mode. 24 for n, 6 for the interest per year. It doesn't, if you've already entered the 6 for the interest per year, you don't have to change it. It'll just stay 6 until you change it. But sometimes with big problems like this, I like to just go in and make sure that I enter it properly. 0 for the present value, 0 for the PMT, and 610, 648.13 is the future value. I'm going to keep that positive. Payments per year is 2, enter. Compoundings per year should be 2 as well. You don't need, it should be changed already. And then I can compute this present value, which is negative 398.4162. And to match it up with our timeline here, that's the pink entry, right? That's this present value. Just kind of figuring out where we are on the map, right? Okay, so close. We're doing great. Here we go. I know n. I know that this present value must be my future value, right? And so let's think about if it's positive or negative. Okay, so I'm making payments. So these values will be negative, right? Or should be negative. And then in theory, I take out this future value and then I invest it right away and I let it sit there and then I take it out and then I invest it right away and then I get money, right? So in terms of positives or negatives, this future value should be positive, right? Because I'm taking it out and then I'm putting it back in. So it makes sense that it was negative here, but when I take it out again, very similar to what we had here, right? This present value becomes, and let's see if I can write it on the right line here, this future value. And while I'm at it, I'm just going to jot it down here, 398.42. All right, rounding to 2 decimal places. Okay, so then I know my n is 180. Let's pick away at this list here. And just so there's no confusion, I'm going to bump that up 1 line. The present value, there is no mention of, and I think I said this before, there is no mention of, oh, you have 20,000 and then you decide to start your paying into your RSP. No, don't worry about it. You start with 0, right, in that case. So the present value of this is 0. And I'm trying to solve for the payment amount. The payments per year, well, it looks like it's monthly, right? And so my payments per year is 12. And I've already got the compoundings per year is 2. And it looks like these payments, and you can confirm by reading that blurb, right? But it looks like these payments are at the end. So then I definitely need my mode to be at the end mode because now I have payments. Okay. Again, Gonna do it on the side here. I'd say the hardest part of this problem is mapping out the timeline, figuring out what you know, what you don't know, what becomes what, and then the calculator entries are not bad, right? So N is 186 for the interest per year, 0 for the present value. I'll do 0 for the PMT for now. 300, 398.42 is my future value. 12 payments per year, enter. 2 compoundings per year, enter. Make sure I'm in end mode. Here we go, compute PMT. All right. I get negative 1,039.440387. What color did I use here? Orange. Orangey, glad I didn't say banana. So, hey, that's pretty reasonable, I think, right? So what this says is that you're going to make payments of, let's say, 1,040, just for a nice even number. So 1,039.44 every month at the end of every month for 15 years, right? So here, 1,039.44, 1,039.44 for 15 years, and then it's going to sit there. And then at the 27-year mark, you'll be able to get $2,000 for 20 years, right? At the beginning of each biweekly period. That's quite a growth, right? Here we're making monthly payments of essentially 1,000, and then we're getting biweekly payments of 2,000. So pretty fun to think about. So we would need to make monthly payments of 1,039.44. Notice that it's negative because you have to make those payments, right? So it's money leaving your hands. But there you have it. And I've still got a minute or two to spare. Not bad. But this is, now you've seen the hardest type of question that I could possibly throw your way. I promise it's not on the final, but there is a quiz like this. Okay? And the quiz, instead of getting you to enter the calculator values, the quiz will just ask you to say what each of these 3 values are, right? So, but it'll be very similar. If you have any questions, let me know. Otherwise, I'll see you Thursday.
Thank you.
Thank you.